Welcome, everyone. In this video, we will be looking at another fascinating architecture known as EfficientNet. We will see what it is, its design principles, its core ideas, and finally conclude by comparing it with some other popular transfer learning architectures. So let's begin. EfficientNet was designed by researchers at Google in 2020. The team identified that careful balancing of network height, width, and resolution could not only improve performance, but also reduce model size and inference latency. The architecture was thus named EfficientNet. EfficientNet achieved state-of-the-art results for the ImageNet dataset by achieving 84.3% top 1 accuracy and 97% top 5 accuracy, while being 8.4 times smaller and 6.1 times faster than the previous state-of-the-art model. It also achieved state-of-the-art on 5 other transfer learning datasets. Let's now understand how the researchers did this. The team did this by designing a compound scaling method as shown in this image. They observed that bigger networks with larger width, depth, or resolution tended to achieve higher accuracy, but the accuracy gain quickly saturated after reaching around 80% accuracy, demonstrating the limitation of single-dimension scaling. They thus formulated that in order to pursue higher accuracy and better efficiency, it was critical to balance all dimensions of the network, the width, the depth, and the resolution together, in a concept they defined as compound scaling. As per this method, the depth, the width, and the resolution could be scaled together by using a common compounding coefficient called phi. They correlated this to the fixed computing budget available to build models. So, if you had available to you 2 to the power of phi more computing resources, you could scale your model to have a depth of alpha to the power of phi, width to be beta to the power of phi, and resolution to be gamma to the power of phi. Through experimentation, they found that the values of alpha, beta, and gamma were 1.2, 1.1, and 1.5 respectively. And so to summarize, to create a customized architecture, you would first need to understand your available computing resources and use that to compute phi. Next, you would use phi to calculate the depth, width, and the resolution, and finally build the architecture using these numbers. A point to note here is that the effectiveness of this systematic scaling depended heavily on the base architecture, though the method performed well with mobile nets and ResNets. Let's now look at some important ideas discussed by the team in their paper. The team pointed that their motivation for building EfficientNet was the fact that many applications required higher accuracy, but newer designs with their single scaling techniques, where they scaled either the depth, width, or the resolution had already hit the hardware memory limit. Thus, to get further improvements, more efficient architectures were needed, which balanced all dimensions during scaling. The team also pointed that while a custom EfficientNet architecture was designed, the concept of compound scaling also worked well with existing architectures like MobileNet and ResNet. Finally, the team used GradCams to perform inference analysis on the model and showed that the EfficientNet model was better at focusing on more relevant regions with more object details than single-scaled models. Now let's do a quick comparison of EfficientNet with other popular architectures like MobileNet and ResNet. While ResNet emphasizes deeper networks for performance, and MobileNet focuses on efficient architectures suitable for mobile devices, EfficientNet provides a balanced approach. It leverages compound scaling, making it adaptable and efficient. It also generates performance, which can beat the focused, singular scaling models in accuracy and detail recognition. In conclusion, EfficientNet is not just another architecture. It is a paradigm shift in how we think about balancing network dimensions efficiently and effectively. Whether you're working on farm automation or developing the next generation autonomous vehicle, you should definitely explore EfficientNet as the architecture of your choice. And that is it for this video. Again, like we mentioned before, we will add this and the other research papers to the resource section if you want to read more. In the next video, we will see how to build both MobileNet and EfficientNet models using real-world data. So, see you there.